The James Webb Telescope has been a groundbreaking innovation since its launch into space. Every day, NASA unveils remarkable new discoveries from the telescope, portraying space as if it eagerly awaits exploration and the revelation of new phenomena. It feels as though we stand on the brink of uncovering something monumental, capable of reshaping our reality. From challenging the world's skepticism about the Great Big Bang Theory to presenting awe-inspiring images of vast galaxies, the James Webb Telescope is revolutionizing our perception of the world. The sheer enormity of the universe surpasses human comprehension. Did you know that as of 2016, an estimated 2 trillion galaxies exist in the observable universe? What mysteries lie within these galaxies? Secrets remain hidden within the unfathomable depths of the universe. Perhaps the true expanse of space will forever elude us. However, technological advancements like the James Webb Telescope and Hubble have significantly broadened our horizons. Considering the mind-boggling revelations from these iconic telescopes, we've begun to comprehend that within the immense vastness of the universe lie great mysteries. It's no wonder that space, being so extensive, is filled with countless enigmas and an array of perplexing phenomena. Recently, scientists made a momentous discovery. NASA revealed an image of a mysterious object that seemingly originated from another solar system, an unprecedented sight. This object, the second known to have traveled beyond our solar system, is 2I Borisov, showcased in never-before-seen images by NASA. In the picture, a distant spiral galaxy is visible beside the comet. However, the image's attention is drawn to the comet's bright blue center, captured by the Hubble Space Telescope as it tracked the comet's journey through space. This image portrays the comet's passage through our solar system as it heads back into interstellar space. In the past, Gennady Borisov, an amateur astronomer, initially spotted a moving celestial object on August 30, 2019, while observing the sky through his homemade telescope. This wandering light, now identified as 2I Borisov, emerged as the first confirmed comet and the second extraterrestrial object to visit our solar system from a region beyond the influence of our sun. Astronomers worldwide hurried to examine this object using some of the most powerful tools available, aiming to gather as much information as possible about this intriguing visitor. Astronomers have since revealed that 2I Borisov possesses an unusual composition. Observations conducted with the Hubble Space Telescope and the Atacama Large Millimeter/Sub-Millimeter Array ALMA of the National Radio Astronomy Observatory unveiled its unique characteristics. Notably, it contains a higher concentration of carbon monoxide compared to any comet observed within a relative distance, around 300 million kilometers, of the Sun. While the possibility of other stellar origins exists, scientists propose that the comet might have formed around a red dwarf, a type of star smaller and fainter than our Sun. Another hypothesis suggests that 2I Borisov could be a fragment of a small planet rich in carbon monoxide. Comets are essentially icy conglomerates composed of dust and frozen gases, resembling snowballs. They typically measure roughly the size of a small town when completely frozen or inactive. However, when heated by the sun, their tails can extend for millions of miles. In the case of 2I Borisov, its estimated length is approximately equivalent to 9 football fields or about 0.98 kilometers. The most recent findings about the comet's composition have been published in Nature Astronomy. Comets, originating from the early material disk surrounding a developing star, retain traces of the distant past of planetary systems. They unveil the elemental history involved in the formation of Earth and our neighboring planets, shedding light on the presence of water. Comets from our solar neighborhood disclose this information, while an interstellar comet, like 2I Borisov, serves as a chemical messenger from a different star system, offering invaluable insights into worlds beyond our reach for space exploration. In October and December of 2019, NASA's Hubble Space Telescope captured images of comet 2I Borisov as it traversed our solar system at an astonishing speed of approximately 177,000 kilometers per hour. The images revealed a bright nucleus, although the nucleus itself was too diminutive for Hubble to discern. Subsequent Hubble images taken in March 2020 displayed a significant transformation in the comet's appearance. Instead of the previously observed singular bright core, these images suggested a fracture in a small segment detached from the nucleus. Scientists continue to monitor the comet using Hubble to track its evolution. The news of Comet Borisov spread worldwide following a week of extensive observations by both amateur and professional astronomers. Through these observations, researchers were able to trace the trajectory of this swiftly moving visitor and confirm its extraterrestrial origin. Scientist Bodewitz and colleagues leveraged the Hubble telescope to observe 2I Borisov between December 11, 2019 and January 13, 2020. Additionally, an international research group, led by Martin Cordina and Stephanie Millam from NASA's Goddard Space Flight Center in Greenbelt, Maryland, observed the comet using the Atacama Large Millimeter/Sub-Millimeter Array ALMA, a network of radio telescopes located in northern Chile, positioned at an elevation of 16,570 feet. ALMA, due to its capabilities, detected cold, low-energy gases present in comets. The high ratio of carbon monoxide to water indicated that the comet likely originated from an icy region comparable to the Kuiper Belt. According to the Hubble-using team's theory, the region connected to our Sun where Pluto resides is associated with a red dwarf, the most prevalent type of star in the Milky Way. This theory suggests that a red dwarf might have served as the origin point for 2I Borisov. The material forming planets around red dwarfs would likely be colder than the elements constituting our solar system due to the smaller size and lower brightness of these stars. Such conditions, low temperatures and luminosities, are conducive to forming comets with constituents akin to those found in Comet 2I Borisov. While researchers speculate that 2I Borisov may have originated from a piece of a dwarf planet rich in carbon monoxide near its surface, they also consider the possibility that it developed as a comet with a notably high carbon monoxide content. Another hypothesis proposes the existence of an exceptionally thick outer layer protecting frozen gases like water and hydrogen cyanide, potentially causing them to appear more abundant as the more volatile carbon monoxide vaporizes or outgasses. The peculiar characteristics of Borisov suggest a greater diversity of carbon monoxide in comets than previously believed within our solar system. Regardless of its origins, 2I Borisov presents new challenges in cometary research. The Kuiper Belt, including Pluto, and the distant Oort cloud are the primary regions in our solar system from where most comets originate. However, the erratic motions of Saturn and Jupiter billions of years ago might have pushed comets farther away from the Sun, potentially propelling them toward other stars. Researchers hypothesize, based on Hubble observations, that 2I Borisov could have been sent toward our solar system by giant planets within a red dwarf system, particularly one with a frozen carbon monoxide climate. The possibility of a Jupiter-sized planet moving inwardly, ejecting numerous comets, aligns with their theories. The comet's encounter with our solar system marked the end of its isolated journey, causing it to emit gases and unveil its interior. 2I Borisov, unlike our solar system's comets, is swiftly drifting away from the Sun and will eventually re-enter interstellar space, never to return. Its trajectory is slightly affected by the Sun's gravitational pull, but due to its path and high velocity, it cannot be captured into an orbit around our star. Being from a different star system, Borisov might differ in age from our 4.5 billion-year-old planetary system. Gravitational interactions, primarily with Jupiter, have historically expelled comets from our solar system. This could be the case for Borisov, ejected from its home system due to similar interactions. While the surface of Borisov has not been directly observed, comets from our solar system often exhibit rough surfaces occasionally covered in smooth layers of ice and dusty debris. Borisov lacks sufficient material or mass to maintain its own atmosphere, resulting in a lack of significant gravitational pull. However, Borisov has developed a coma, a dust-filled cloud of gas surrounding the comet's nucleus. This coma forms when ice is heated by solar energy, causing dust to brush off the comet's surface and disperse into space. David Jewett, a professor of astronomy and planetary science at the University of California, Los Angeles, whose team captured detailed images of this first interstellar comet, explained the significance of Hubble's data in determining the nucleus's size, an essential element of Comet Borisov. Their Hubble images unveiled a nucleus significantly smaller than previously hypothesized, measuring no more than 500 meters in radius, almost 15 times smaller than earlier estimates. This finding is crucial as it aids in estimating the total number and mass of similar objects in both the Milky Way and the Solar System. With Borisov being the only observed interstellar comet, scientists are eager to ascertain the prevalence of such objects in space. Oumuamua, another extrasolar visitor officially identified in 2017, rapidly exited the solar system after passing close to the Sun at a distance of 24 million miles. Due to its incredible speed, scientists could not gather extensive information about it. However, more recent measurements indicating slight acceleration prompted a reclassification as a comet, despite ongoing debates about its true nature. This comparative analysis could offer valuable insights into the nature and diversity of objects traversing our cosmic neighborhood. If you found this video informative, make sure to subscribe to our channel for more content.